Okay, hello. You need three pieces of paper, okay? You got the two that I kind of gave you. These are going to be the examples we're going to do. This is going to be where the assignment's going to be done, okay? And you also need your root sheet, okay? That radical sheet that I passed off. Remember, these are your cubed roots, okay? The fourth roots and the square roots, okay? Remember, without the number in the index, it's a 2 automatically. You also need a calculator, okay? All right, now, let's kind of split this up into two parts, okay? So it's multiply and then simplify, okay? Now, because both these roots have the same number in the index, I'm allowed then to make a fourth root and then just multiply the 8 by 32. Okay, I'm allowed to multiply them if the root indexes are the same. You got a 4 and a 4, so we're going to take 8 times 32. That's 256. Now after that's done, I simplify that. First I try my calculator. 4, second, and then remember the upside down V, like that, and then 256. Okay, I did not get a decimal. I have my answer, 4. Okay, easy enough. Now on this one, again, now I would make a root, but they would both be cubed roots. So I take 9 times negative 24, negative 216. Okay, and then I use my calculator. So 3, second, upside down V, negative 216. Okay, I'm good with negative 6 as my answer. Voila. Okay, now the radicals don't have an index number, so that means you automatically use a 2. It means a square root, okay? So I make a square root, and 3 times 4 is 12. I'm going to attempt to do the square root of 12, so second, it's not 6, okay, so don't divide 12 by 2. Okay, I got a decimal. That's an irrational number, so I don't want to write that down. So it's a 2, okay? So since it's a 2, I want to look at the list right here, okay? These are my perfect squares. I divide into the 12, and I want to attempt to rewrite that into square roots, okay? So if you get an irrational decimal and put a division sign after your 12, we're going to rewrite that into square roots. So the first number that is lower than 12 from this list here would be 9, okay? And also get rid of the 1s. I don't even know why I put those, okay? And go to the other side too. Might as well get the 1s out of there for future things because I don't want to confuse you with that. So get those out. So I start trying to divide 12. So 12 divided by 9 is not going to work. 12 divided by 4 does work. It's 4 and 3, so I want to put a 4, the number I got from this list, into the first radical, and then the answer I got into the second. Okay, now I replace the first radical, get rid of it completely because it was the square root of 4, and that's equal to 2. Okay, so you have your answer. You just put 2, and then the square root over 3, just like that, okay? Okay, then the last one of these. Okay, we have 2 of the same root and a multiplication problem. I'm allowed to then combine them into one root and multiply negative 7 times 49. That's negative 343. So I go 3, second caret, negative 343, negative 7 is what I come up with. Now here's what you should do, okay? Pause this video and work on problems 1, 2, 3, and 4. Trust me, it'll help if you split it into 2 rather than watching everything and then going back and doing it. Pause the video, do 1, 2, 3, 4. And then when you're done, resume the video. Now I'll teach you how to do 5, 6, 7, and 8. Okay, now in this part here, I'm going to teach you how to simplify radicals and variables. So we have a cubed root, okay? So what I'm going to do is split this. I'm going to split it into the cubed root of 54, the cubed root of y to the power of 10, and the cubed root of x to the power of 5, okay? Now, don't just divide 54 by 3. When the cubed root of 54, I'm going to take it to my calculator first. So 3 second upside down v, 54. Got a decimal, okay? So I make a parentheses, I put a division sign, and I attempt to rewrite that into 2 numbers that multiply to 54, and the first number I want to be a perfect cube. But I'm not going to look at this sheet because that's square roots, okay? I turn the sheet over, and these are my cubed roots, okay? So these will be the numbers I'm trying to divide by this time. Okay, so the first number higher, so remember 54 is my number I'm trying to factorize, divided by. I would start at 27 because that's the first number that is lower than 54. And that works. So I rewrite that as 27 first and then 2. And I replace with the cubed root of 27 with what it equals, which is 3. Okay, now here's what you do then there. You still have to do these, but what you will do is make a cubed root, and you will put 3 on the outside. Now give yourself some room because you're going to have some letters that come outside here. And then that 2 goes on the inside. Okay, now y to the 10th. Here's how we simplify y to the 10th, okay? See, you're not going to be able to just make a parentheses, put a 3 outside, and divide 10 by 3, because 10 divided by 3 is, you know, that. So here's what you're going to do. You're going to write out 10 y's. I know this sounds kind of goofy, but I think it'll help you understand it. Now you're going to circle 3 at a time, or actually you're going to put a root over 3 of them at a time. So right there, there's 3 of them. Right there, 3 at a time, okay? Right there. And right there. If you have one at the end, just put it in its own root. 3 at a time because there's a 3 here. That tells you how many to put over at a time. Now this guy at the end here, this y I have at the end, there's only one of them. I'll put him inside of the root, okay? Now, how many of these other roots do we have? So we have the cubed root of y of 3y, so it'd be y to the 3rd, cubed root of y to the 3rd, cubed root of y to the 3rd, okay? Now, here's how this works. Every time you're able to do a full threesome, a full trio, put a y above it, okay? Now, how many y's do I have that are above it? 1, 2, 3. So outside, you're going to put y to the 3rd power. That's our answer. So every group of 3, I just put a single y above it because the cubed root and y to the 3rd would cancel, and I would get y. Y to the 3rd with a y left in the root. Now, x to the 5th. You do it the same way. No, this isn't the answer. I got to do the x's. 1, 2, 3, 4, 5. So remember, put that root over 3 of them at a time, okay? 3 at a time. And then I can't do 3 more, so I just put a root over what's left. Okay, these two at the end, right? Okay, so I'm going to have an x above that one because there's three of them. Here, I can't put an x above it because there's not three of them. There's only two of them. So these ones that I had left over here, I put x to the second because there's two of them inside. Okay. Then how many x's did I put up on top? I just put one. Okay, so x. I'll just put x right there. Okay, next problem. Again, so split that up. So you got the fourth root of 625. You got the fourth root of x to the third, and you got the fourth root of y to the 18th power. Okay. So here's what you're going to do. So the fourth root is 625. Okay. Make your fourth root down there first. So first I try my calculator. I don't need to do this nonsense with the parentheses and the dividing if it comes out to a whole number right away. So I go 4 second caret 625. Okay, I got 5. So I don't need to do that. Now you're like, where do I put that 5? If it's square roots and you get that 5, that needs to go outside. Okay. Now, x to the third means you're going to write x times x times x. Now, you're going to put a root over 4 of them, but you can't do it, okay, because you only got 3. So just put a fourth root over that 3. And since there's only 3 instead of 4, you can't put an x here. So that would be 3 x's in the root, okay, so x to the third. Now, y to the 18th, y times y times y times y times y times y times y, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now we're rooting 4 of them at a time, so make a fourth root and put a y on top. Make a fourth root, put a y on top. 4 of them, fourth root, put a y on top. Fourth root, put a y on top. Fourth root, you can't put a y on top because you didn't get a full group of 4. So right away you know that there's going to be a y to the second because there's 2 of them inside the radical. Now, how many y's were we able to put up top? 1, 2, 3, 4. So it'd be y to the fourth out here. Okay. Okay, next one. Simplify. So I write root over 50. And again, if you don't have an index, it's a 2. It's automatically a 2. Okay. And then the square root of x to the 5th. Okay, now let's try to calculate that first before we have to use this sheet. So 2 second caret 50. Okay, decimal doesn't fly. So which list would I look at? Well, I wouldn't use this list because it's not a cubed root. And it's not a fourth root either. It's a 2 in the index. So that means I'm looking at the big list here. Okay, or the list up on the board in the front of the room. So again, what I'm trying to do is divide into the 50 and rewrite it as 2 cubed roots. Okay, and I will be replacing this one, hopefully. So 50 divided by 49, decimal. 50 divided by 36, decimal. 50 divided by 25, not a decimal, stop. So I write 25 and 2. So I replace this and I just put 5, okay, 5. So I make a radical, it's still going to have a 2 in the index, and that 5 goes out here, and that 2 goes in. Again, the one I cross out and replace it goes out, and the 2 goes in. Okay, now x to the 5th, this is a short one, x times x times x times x times x. Now the radical degree 2 tells me how many groups we need. What do I put? So I'm going to put the radical over 2 of them at a time because that's a 2. So 1, put a 2, and then an x can come up here. X up here. X cannot come up here because we didn't get a full group of 2. So that x there at the end, I put inside the radical. Now, how many x's did I have above it? I have 2, so it's x to the second power. Okay, next one, the cubed root of 32 a to the 5th. Okay, so I rewrite this, the cubed root of 32 and the cubed root of a to the 5th. Okay, so remember with the numerical, first I go to my calculator, I go 3 second caret 32. I got a decimal, that isn't going to fly. Okay, 32 divided by 25, then since I didn't, sorry about that. Since I got a decimal, I have to put divide, and I try to rewrite that into 2 cubed roots. Now, it's not a square root, okay, so we can't use this list. We have to flip it over and use it where it says the cubed roots. So 32, I'd start with 27, trying to divide 32 by 27. It's a decimal. Then I move up to 8, 32 divided by 8. I got 8, 4. So 8 and 4. So I replace the first cubed root. That is equal to 2. Okay. So I make a cubed root. And the 2 is going outside. And the 4 is going inside. Okay. Just like that. So again, always replace this root with the number that it's equivalent to, which is equal. A to the 5th, so I got a times a times a times a times a. It's a to the 5th. Now I want to group them. I want to put radicals over 3 of them at a time. Okay. So there's 3. Then that allows you to put an a up here. You can't do another 3, so you just got to put a radical and just leave it. You can't put a up there. That means you'll have 2 a's, 2 of them that are inside. To a to the second. It's a to the second, not 2a. A to the second. Now, how many a's was I able to put on top? I was able to only put 1, so I would put a, or a to the first, outside. Okay, let me know if you have questions.